Hey there, in this video we're talking about file type parameters being sent into functions and working with multiple files at the same time in C++ programming. And this covers sections 12.3 to 12.6 in the Gaddis C++ book. So it was the last video where we got our introduction to advanced file handling, and now we're certainly able to save lots of information onto secondary storage like a hard drive or an SSD flash drive or something like that. And we can retrieve a whole lot of information very efficiently without having to type it all in repeatedly. So we're in a pretty good position with that. We're still working with text type files that are human readable. In the next video, we'll start talking about binary files. But before we get there, we want to be able to do this in our programs. So first of all, passing file stream objects into functions. Now again, a little bit of philosophy we come back to over and over again. We want our programs to be modular with functions that do one small task each so other programmers can read just a little snippet and understand what's going on there. So of course, we're going to need to be able to pass file stream objects to functions. And you can do that, basically just like any other kind of variable or structure, frankly. One little detail is, remember, you have to always pass your file stream objects by reference. And the reason for that is that the objects, among the things that they're tracking internally, is they're tracking a read position within the file that updates on any operation. So like in the last example, in the last video, we had a file that had a bunch of numbers at 100, 200, 300, 400. So as each of those things gets read, the file object has to keep track of how far into the file have I read in order to determine what's the next thing that I'm going to get out. And basically that's just an integer keeping track of where am I in the file currently. But every single file operation, either reading or writing, is going to change that. So since something's changing in the object, you have to pass it into a function by reference so that you're actually making the change in the original object and not a copy. If you forget to do that, then things are going to get scrambled up and maybe you're going to be reading the same thing over and over again or something like that. Back in chapter 5, where file handling was first discussed, there's actually an illustration of the file read position. So if you want a little bit more insight to that, go back in the book in chapter 5 and have kind of a fuller conversation about the read position, but hopefully that makes sense. So here's an example of that, passing file stream objects into functions so that every function does one little thing. This program demonstrates how file stream objects may be passed by reference to functions. So of course, we're including the fstream library as usual. And on line 9, there's a prototype for a function called openFileIn. So clearly a dedicated function that just opens a file for input. That's all it does. And as you can see here, it takes an fstream reference for the file stream object to be opened, and a string parameter here that I think is going to be the file name on the drive. And then here's a function called showContents, which apparently is just printing the contents of the file to the screen, I assume. And again, that takes one parameter that's an fstream reference that's presumably a file that's already been opened. And then you can just focus on the reading in that function. You know, let's go and actually look at, on the next slide, let's actually look at what those functions do, and then we'll come back to the main function. So openFileIn is here, right? openFileIn, you come in with this fstream reference called file and a string for the file name. Very, very simple. Mostly this is just demonstrating how to pass file stream objects into functions, so nothing really fancy here. So sure enough, you do file.open with that particular fstream and the ios::in, because this is for input, of course. And then they're going to check that member function that we talked about last time. There's a member function inside the file object called fail. So just to do something with that, it checks if file.fail is true, then, because it actually failed, this function is going to return false, indicating to the caller that we did not successfully open the file. Otherwise, we return true. Okay, so hopefully that makes sense. Just a function that just does one single simple job of just opening a file for input and then passing back true or false whether that worked or not. Now on the next slide, we've got showContents. Again, very, very short. We like short. It's very easy to understand. So in comes this file stream reference that presumably has already been opened. And there's a variable called line, because we're going to get this text information out of the file. Here is that while loop we talked about last time. because the extractor operator, the right arrow there, returns true or false, depending on whether you're successfully reading something. It becomes false at the end of the file. So you're going to read in a line and print it out. And you're going to read in another line and print it out. Okay, and so on and so forth to the end of the file. That's a good function. It shows all the contents in a text file. Okay, let's go back and look at the main function now. So you put that together and you declare an fstream object called data file. Always declare data is probably the first thing in the main function. You call that open file in function. Hopefully this gets opened up. And if so, it's going to print out file opened successfully, now reading data from the file. Pass that file stream object to show contents. Everything in the file is going to get printed to our console. And then, of course, close the file and then print done to the console. Now that's what happens if open file in returns true and you actually successfully opened it. So the other part of that if statement is over here, right? You hit this else, and then you get an error message that says file open error if you don't successfully open the file. All right, so hopefully that makes sense, and you can see what the book claims is going to happen if you run this program. We should test if that always happens, or maybe sometimes something else happens. So here I'm going to test this program 12.5, and as usual, I've made a dedicated folder. I've got the source code file, pr125.cpp here. I've pulled out the data file that goes with this program, demofile.txt, put it in the same folder. Again, you want to keep those things organized in the same place, and the data file has to be in the same place as the program, so that's kind of important. You know, let me actually inspect. I like knowing what's in my data files before I try to program against it, so let me just open this up. And that has these 4 names here, Jones, Smith, Willis, Davis. Okay, got it. And having understood that, now I'll compile this program. Okay, so successfully compiled. And of course, that made this pr125.exe, which as usual is the whole point of compiling. And now I can run this and see what we get in the console. Great, yeah. So that actually does successfully read all 4 names one after the other and throw them up on the screen. So a good example of using file stream objects being sent to small modular functions that just do one thing, the one function to open it, the one function to actually print all the stuff on the screen. That actually does work. Now, you know, let me just think about this error handling here. There's this if-else that we really ought to have in these programs, checking whether the file was successfully opened or not. So why would it not successfully open? Well, the main thing is, what if the file wasn't there? What if the data file wasn't there? So if I take this file here and I move it to a different location, like maybe I'll just move it onto my desktop here, which is a different location. Notice that's not in the folder with the executable now. Now when I try to run it, I get this error message. I get the file open error down here from line 25. So in this case, the program ran, looked in the folder where it is, that's called the working directory of a particular program, couldn't find demofile.txt, so that attempt to open it failed, and you land down here on this error message. Now, if I just move that file back in the same location, this will work again. Okay, now my program can find it. So make sure that you have your data file in the same location as your program, specifically the executable file. I mean, hypothetically, you could give a whole path name. So if you knew that the file you wanted was in c:/users/alice/mydata/demofile.txt, you could actually put that whole path name here, and that would also work. But probably a lot easier to just put the data file in the same place as the program. I will say that sometimes I have beginning students come to me and go, my file handling program just isn't working. And usually the very first question that I ask them is, did you put your data file in the same place as the executable? And if their response is, I don't know what you mean by that, that's probably the problem right there. So make sure you actually do have your data files in the same folder as the program, as the executable. All right, and some more things you can do with files. Here's some more file stream member functions. Now remember, these are members of your objects, just like member data is part of a struct. So if you have an open file and you want to call this first function, you're going to have to call file, whatever the name is, .get, or name of the file .getLine, or name of the file .put, right? These are all member functions that you get at with an open file and the dot operator, then this function. So among the things you can possibly do to control text input a little bit more finely, you don't have to use the left arrow, right arrow operators. This function called get takes a character reference, and what that does is it reads in one single character from the stream and stores it in this character C. So keep in mind, as usual, just like with sin, if you use the right arrow operator, the extractor, that tokenizes the stuff in your text and breaks it up on white space. So if I have New York City and I call the right arrow operator with sin or a file, it's just going to get new and it's going to ignore that space. This next time I get it, I'll get York, and you'll never actually see that space. So if you want to read individual characters and see every single character, including spaces, you could use this. Just gets one single character at a time, including letters and digits and spaces and tabs and whatever. Now, that function is overloaded. The get function is overloaded. You can also call it with two parameters, where the first parameter is a character pointer, presumably where you want a C string to be sitting, and the second parameter is the number of characters that you have available space. So that'll actually read in n characters from the open file stream and store them in this C string S. So getting a whole bunch of characters at once. Then there's this getLine function. I believe we've seen that before in the class. So the getLine function that works with sin or a file, whatever, similar to that last one. This is going to read up to a new line. So it's going to read up to the enter symbol, hopefully at the end of a line. No more than n characters, so you're controlling the size properly so you don't have a buffer overflow, and stores them in this C string called S. I guess maybe we've seen a version that works with C++ strings in the past, but this version also works with C strings, so that's good to know about. And then here's a function called put that takes one single character and writes that one character to an output stream. So a bunch of options there to more finely control your input and your output. And you can do this kind of stuff with C++ strings, and you can also do it with C strings that sometimes we're focused on a little bit more in this class. All right, so the other thing we wanted to talk about today is working with multiple files. You can certainly have more than one file open at a time in a program. Our prior examples only had one, but you can have 2 or 3 or 4 or 5 files that are all opened at the same time. And those files can be open for input, like I could have 2 files open for input, and I could have 5 files open for output. There's really no limit, so to speak. You're going to have to define file stream objects for each file, of course. So a separate variable, really, keeping track of each of the files that's open at the same time. And a lot of programs do this in the world. Programs that take one file and translate it to another file are generally called filters. So it's pretty common to have like one file open for input, and then you're reading and you're doing some kind of processing, and you're writing the results to an output file as you go along. Pretty common. It's called a filtering program. So here's an example of that in program 1212 in the book. This program demonstrates reading from one file and writing to a second file. So of course they're including the fstream library for all this stuff. Now the data that they're declaring in the main function here, we're actually going to ask the user for the name of the file to open up and process. This program is actually going to be able to do this with any type of text file. So we ask the user, what's the name of the file you want us to work on? Of course, if you're reading information from an input file, you have to have a variable to store that data. So on line 12, they're making one single character variable called ch just to hold one byte's worth of text data at a time here. The first file that they're declaring here on line 13 is of type ifstream. Remember, that stands for a dedicated input file stream, and they're calling it infile, which makes sense as a name. On line 16, they're declaring the second file object, and this is of type ofstream, a dedicated output file stream. They're calling it outfile, and they're actually connecting that. They're actually creating a new file on the hard drive called out.txt. So remember, you can declare a file and also open at the same time, kind of initialize it like this. So that's what they're doing. Now, on the next couple lines, they're asking the user for the name of the file that you'd like to open up, and the user sends that into file name. Line 23 is where they're going to open the input file. There's a little bit of a typo in the book on this, actually. I think maybe they took this from a different program. So that line should have been infile.open parentheses file name is what that should have been. So again, send in the name of the file the user just told us about. And for an ifstream object, you don't even need the ios : in, because that just does it automatically for us. That's the kind of thing you need for an fstream object. Anyway, when you look at the code repository with the book, they actually do have that correct there. So let's see. So here we are verifying that the file was actually opened properly. We saw that in the last video. Here's actually a third way to do that, is the name of the file object itself actually hands back true or false depending on whether it's currently open for input here. So you can actually just put if in file as your if statement here, and that checks whether it's currently open. If that's the case, then what we're going to do here is, and this is the second way of managing input from a file of unknown length that we talked about last time. So we read one piece of information first. So we're calling infile.get. There's that member function that we talked about there. So just get one single character's worth of information out of the file. It could be a letter, could be a space, right? We're going to get all that stuff. And then here's the while loop, while in file. So as long as you have not hit the end of file marker, this is going to be true. And you're going to go in here, you're going to do output, you're going to do outfile.put, right? Printing just one single character, taking the character that you read and converting it to uppercase. There's the to upper function that we saw back in chapter 10, actually. So whatever character you read, convert it to uppercase and print that one character to the output file. And then on line 39, we're about to go back to the while statement, then read in one more byte. Do infile.get and get the next character in this byte and go back to line 33. If that worked, if infile is still reporting true, you're going to go convert it to capital, print that to the out file. So between line 39 and 36, you're bouncing back and forth between the input file and the output file, reading one byte, converting it, printing it out. So pretty good example of a filtering program. Once that whole process is over, once you've hit the end of file for your input file, you get out of the while loop and you have to close both of those files. Don't forget to close both of those. Infile.close, there's outfile.close, and a little report to the console so the user knows that the file conversion is done. Now, if that attempt to open the file failed, then instead you're going to land down here on line 48 and it's going to say cannot open whatever that file name was. So a good example of both filtering and also validating that the file was actually successfully opened before you try to do stuff with it. So that's a pretty well-structured program. So I certainly want to test this program 1212 here. As usual, I made a dedicated folder. I got the source code file, put it right there. And fairly simple program, does a fairly simple job. It's going to open one file, read one character at a time, turn it uppercase, write it into the second file. So obviously I should compile this. And that makes pr1212.exe, obviously, when you successfully compile it. So now I need an actual text data file to test this against. What should I do, actually? You know, I'm going to bring a web browser on screen, and I'm going to go to a site called Project Gutenberg. And, you know, maybe you've heard of this before. It's a site that's dedicated to free books. So there's Project Gutenberg right there. Totally legal. They've been around for over 50 years, and just anything that's legal to redistribute should be on Project Gutenberg for a book, actually. And I'm going to just search for something popular, frequently downloaded page here. So here's the top 100 ebooks from yesterday as I record this. And just looking for something that I recognize. I mean, there's Little Women. I could use that. Here's the complete works of William Shakespeare. Let's do that. I'm just going to download everything that William Shakespeare ever wrote. It's kind of nice that they have a bunch of different file formats. They've got HTML web page formats. They've got EPUBs for the Kindle. But what I want here is the plain text version, because that's what our initial text handling programs are set up to deal with. So I'm just going to save this into that folder right there. Great. So I just got everything by William Shakespeare in that file here. It's called pg100.txt, I see. I can put this away. Just going to open that up and kind of inspect that. So some boilerplate from Project Gutenberg, table of contents, everything William Shakespeare ever wrote. So starting with the sonnets, 1, 2, 3, 4, 5, right? It's got all the plays in here. King John, Julius Caesar, King Lear, of course, The Tempest, all that kind of stuff, down to Venus and Adonis. I guess it's the last thing there. So good. I think I get that. And now I'm going to run this program. And remember, this program asks the user for the name of a file. So I'm going to type in pg100.txt. Go to hit enter. And see, this program's already made out.txt, right? That's the name of the output file that it makes. And now I just hit enter and we'll see it do its processing. Here I go. And it's done. Great. Okay. So, most of that run was waiting for me, the user, to finish typing in the name of the file. The actual processing of the file took less than a second. Very fast. Let's go and see the results in out.txt. Okay, so now there's everything that William Shakespeare ever wrote all turned into capitals. And all the sonnets and all the plays and everything got translated into uppercase, if that's useful for some reason, in clearly less than a second. Great. So once again, kind of a good example of the power of a modern computer processor is that program is really doing all that just one character at a time, right? That line 39 got hit, I don't know, 100,000 times right there, but it's perfectly willing to do that one character at a time and do that like 1,000,000 times a second, and thereby convert the entire works of William Shakespeare to capitals, and that's what that program does. Nice, nice. So of course, we should just test this to test the input validation. So if I run this and I type in the name of a file that isn't there, okay, like I'll just put in something.txt. Okay, well then of course it's going to say cannot open something.txt because when it tried to test it on line 26, that actually failed, and then you land on line 48 and you get the error message. So once again, good to have the input validation there if the data file has been misidentified by the user, or it's missing, or it got deleted or something like that. That's why you need that check. Right, but a simple program that on the other hand does something that's very powerful. So I kind of like that example quite a bit. And here's some more details about how file stream objects manage their state and keep track of whether they've got errors happening or not. Is the file stream objects, among the many pieces of data that they've got inside them, they have these specific bits that act as flags, true or false, for specific process states. For example, they have a bit called EOF bit, which tracks whether you've seen the end of the file or not. That's actually what you're testing when you call the EOF function, is whether that bit is in a 0 or a 1 state, as a matter of fact. There's a bit for the fail bit that's set when an operation fails for whatever reason. There's a hard fail bit when there's an error and there's no recovery from it. As a matter of fact, that would be really bad. There's a bit called the bad bit when an invalid operation is attempted, like, I don't know, maybe trying to write to an input file or something like that. There's a bit called good bit, which tracks, I don't have any errors at all yet. And so you have these member functions that we've seen, like EOF or the fail function. There's also a bad function and a good function to test individually the state of these flags. And then generally, as long as you don't have a really, really bad error, if you do have one of these errors, you can clear them with the clear member function. So if there is some kind of minor problem that threw the fail flag, you can call file.clear to clear it all out, and then you can start working with that again. So these are some details. I don't use all these in my own programs, but you should know about them, and they make for good test questions, frankly. All right, so that's the end of this section on text file handling. And we saw passing file stream objects into functions to keep our programs modular. And we also saw an example of a filtering program where you've got input and output happening at the same time, which is all possible. So my students and I would get together for this lab here where we get to practice files as parameters and handling character data, one byte at a time with the get and the put functions like we saw in the example there. So there's this program here called grades, and it comes with a text data file called graderoll.dat. So of course we're going to have to get those in the same folder together. I would inspect the data file first. I just load it up in Notepad. And generally speaking, when you are working with files, you, as the programmer, you need to be aware of the format of the file that you're working with. So you really need to look at the data file first before you know how to structure your code to deal with that kind of thing. One thing here is that the names in this data file occupy no more than 15 characters. So what the program winds up doing is it winds up using C strings of that size to store the names. And then we're going to read in a whole bunch of data to an array of structures, including names and numbers and addresses and stuff like that, and print them to the screen. Now, I will just kind of highlight that, yeah, this lab uses a fixed length character array for the strings. It does use C strings now. For most purposes, that's actually not what you want to do. Let's admit it. C++ string objects are frankly safer and easier to use. So most of the time, you should expect to use C++ string objects and not get completely fixated on the old school C strings like this lab does. But you should know about both. It's not bad that we're going to get a little bit more practice working with C strings, and we will actually need C strings in the next video when we talk about binary files, because it's much, much, much easier to work with fixed length strings in the binary files context. So before we get to that next time, it's not bad to get a little bit more practice working with fixed length C strings, and that's what this lab is set up, and I don't mind that that's the case. So we'll do this with my students, and we'll come back next time for the discussion about binary files. Remember, that's files that are not stored in ASCII format. They're not intended to be human readable. They are just raw binary, but that's what you're going to do for music files and movie files and game files and pretty much anything else in the world. So very, very important, and I'll look forward to seeing you for that.